Hello everyone, welcome to Gradeup. So today we are starting with the topic of friction. Okay. So friction. So today we will be learning about the concepts, that what is friction, how that friction force acts in the linear motion. Okay, we will understand the basics of friction and the friction in linear motion. First of all, let us understand what we mean by the word friction. Friction is, you can say, it's a force distribution at the surface. Force distribution at the surface, and it acts tangential to the surface. Acts tangential to the surface. Okay. So if this is a body, if suppose this is a body, okay, lying over this plane, this is a plane, and there is a body A that is lying over this plane. Okay, so at this contact surface, at this level, at the macroscopic level, it may appear that this contact is very smooth. Okay, but if we go into the microscopic level, if we zoom this out, we will find out that at the contact surface there are some kinds of roughness that is present. Okay, so this kind of roughness causes the resistance to the motion between the surface and the block. Okay, and that resistance is only known as the friction. Okay, so this should be clear that what is friction and how what are the causes. The cause of friction, you can say, the microscopic level of irregularities in the surface. Okay, or you can say microscopic level of surface irregularities that are present, that causes the friction, or the resistance to the motion, that is nothing but the friction. Okay. Now this friction is divided into two parts. This friction is divided into two parts. One is static friction, and the other one is dynamic friction. Okay, this is experienced by the body when it is at rest. When the body is at rest, this force, this friction force experienced is known as static friction. Whereas when the bodies are in motion, okay, when the bodies are in motion, then time the friction force which is experienced by the body is known as dynamic friction, and it is also known by another name, that is kinetic friction. That is known as kinetic friction. Okay, and this kinetic friction is further divided into two parts. One is a sliding friction and the other one is a rolling friction. Sliding friction is when the body slides over each other, there is a sliding friction, and when the bodies roll, there is a rolling friction. When the bodies rolls. Okay, and the sliding friction is higher than the rolling friction. You must know that. Okay. So this is the classification, the broad classification of friction into two parts: static when the bodies are at rest, dynamic when the bodies are in motion, also known by the kinetic friction. It has got the two parts. One is sliding friction when the bodies slide over each other, and the rolling friction when the bodies rolls over each other. Okay, so now let us see further into this friction. Suppose a heavy box is kept on this surface. Okay, and we start applying a force of, suppose, 10 kilonewton. Suppose, by any means, this is a heavy box that is kept on the floor, and we are applying the force of 10 kilonewton here, but this box doesn't move. Okay, so where is that 10 kilonewton of force that we are applying on the box, where that force is going? Because there is no displacement, we can say here. Okay, because according to the first law of motion, according to the second law of motion, if some force is applied to any body, then it must show or experience some kind of acceleration according to the Newton's second law. But if we are applying the force of this 10 kilonewton, but this body is not moving, that means that it is getting some resistance from this side as well. Okay, and that is equal to this 10 kilonewton only. Okay, that is why the body is not moving. We are applying this force. It is experiencing the force of equal magnitude from the opposite side, and the body is still in rest position only. Okay, so what we do next? We increase this load to suppose 15 kilonewton, but still the body is not moving. That means there is still a force of 15 kilonewton. Okay, so this force we have increased by some means. Okay, either there were earlier 4 people pushing this one, but in the case of 10 kilonewton, now there are 6 people pushing it, so the force have increased to 15 kilonewton, the applied force. But how come this force have increased? This force was earlier 10 kilonewton, now it is 15 kilonewton. How this force is increasing? There should be something by which this force is increasing. Okay, and still the body will not move. But if we increase this force again, if we employ 2 more people to push it, and if we say that this force is 20 kilonewton, and now the body starts moving. Okay, now this force is not equal to 20 kilonewton. Now suppose this body starts moving, and this force, if we calculate, come out to be 18 kilonewton. That means this 18 kilonewton, in this case, now you see the first case, the applied force and the resistance what we are getting. In the first is what, 10 kilonewton, here also it was 10, here it was 15, we increased to 15, here also it increased to 15, but here when we are applying this 20 kilonewton, this only increased to 18. That means this 18 kilonewton is the maximum limit up to which this force can be increased. After this, this won't increase. Okay, and the body starts as soon as we apply this force equal to this 18 kilonewton. As soon as we apply this force 18, okay, at 18 it won't move. At 18.1 kilonewton, this body will start moving. Okay, so this value, this higher value or this limiting value of this frictional force that is being offered by the surface, that maximum value or that highest value of that resistance force or that friction force is known as limiting resistance or limiting friction. This is known as limiting friction. Okay, so the frictional force will increase only up to a limiting friction. Okay, beyond that, if we increase the applied force, the body will start moving. That means for the motion of any body, the applied force must be greater than the limiting friction force. Okay, so whenever this body, the applied force on a body is less than the limiting friction, the body will not move. Okay, these all statements you must carefully note down. Okay, so there are 2 points which I said, or basically 3 points, that the highest value of the friction force at which the motion starts is known as limiting friction. If the applied force, this was the first statement. The second statement says, if the applied force is more than the limiting friction force, then the body will be in motion. Second point. The third point says, if the applied force is less than the limiting friction force, then the bodies will not move. There will not be any motion between the bodies. Okay, that should be clear. Okay, so I am not defining the limiting friction. I have already told you it is the highest value of the friction force at which the motion between the bodies start. Okay, so now see one more important term, that is known as normal reaction. What is that normal reaction? If this is the body resting on any horizontal plane, okay, if this body is in equilibrium, the weight of the body will always act down in the downward direction at its center of gravity. Okay, and if this body is in equilibrium, that means there must be some force that is counterbalancing this weight. Otherwise this body will, if it is acted upon by this force mg in the downward direction, then there will be an acceleration in the downward direction. Okay, but that is not happening because we are saying that the body is at rest on this surface. That means that there should be some reaction force that the body is getting or experiencing in the upward direction, and that upward reaction is known as normal reaction. Okay, and that normal reaction in this case is equal to the weight of the body. Okay, why this normal reaction is important? This normal reaction is important because the friction force is directly proportional to this normal reaction, More the normal reaction, more will be the friction force that will be experienced by the body, and friction force is directly proportional to the mass. Okay, that means more the mass of the body, more will be the friction force experienced by the body. Okay, this is important. Okay, got this? Okay, now if we draw a curve between a applied force and the friction force on the y-axis and the applied force on the x-axis. Initially both the forces are 0. We are starting increasing the applied force. The friction force also increases up to which limit? Up to suppose this limit. Okay, then the friction force has a value, means up till this the bodies are in equilibrium. This is the zone of equilibrium up till which there is no motion between the bodies. Okay, and as soon as the motion starts, this friction gets down and it becomes a constant. Okay, so this value of friction is known as the limiting friction, the highest value at which the motion starts. This one is basically the zone of static friction, and this one is the zone of dynamic friction, because here the motion has started at this point after we apply the force that is greater than the limiting friction. Okay, so this will be a straight line. Got this? Okay, now we will see one more important term, that is known as coefficient of friction. Coefficient of friction. Coefficient of friction is defined as the ratio of limiting friction to the normal reaction. This is the limiting friction and this is the normal reaction. The ratio between them is known as the coefficient of friction. Okay, that is why this force comes out to be F equal to mu r, that is the friction force. Okay. Now the friction that we talk about, now we move on to the laws of friction. Okay, laws of friction. Since the friction are of two types, static and dynamic, the laws will also be of two types: static friction force, laws of static friction and laws of dynamic friction. Okay, so we will consider them one by one. So first write down laws of static friction. Laws of static friction. Okay, it says first, it says that the frictional force always acts in a direction, opposite to which the body tend to move, because this is the case of a static friction, so the body will not actually move but tends to move. Okay, so the frictional force always acts in a direction opposite to which the body tends to move. Okay, second is equal to the magnitude of frictional force is exactly equal to magnitude of applied force. Okay, this is exactly equal to the magnitude of applied force, because this is the case of a limiting friction, means the static zone, that means the frictional force value is less than the limiting friction. So in this case, as we start on increasing the applied load, the frictional force also increases and its magnitude is exactly equal to that of the applied force. Okay, second one, the ratio of F by R is equal to constant. Okay, that is equal to, we can write in this case as mu s, that is mu static. Okay, fourth point, frictional force is independent of areas of the body. Okay, frictional force is independent of the areas of body. Okay, and it depends upon roughness of the body. Depends upon roughness of the body. Roughness of the body means this coefficient of friction. Okay, so these are the 5 statements, the 5 laws of static friction, that is frictional force always acts in a direction opposite to the direction in which the body tends to move. First, its magnitude is exactly equal to the magnitude of the applied force. The ratio of F by R, that is known as the coefficient of friction, is constant. Fourth point, frictional force is independent of the area of the body. And the fifth point, the frictional force depends upon the roughness of the body or the roughness of the surface. Surface would be more apt word here, that is surface. Okay, now moving on to the case of laws of dynamic friction. Laws of dynamic friction. The laws of dynamic friction. The first one is same, always acts in a direction, always acts in a direction opposite to that of, opposite to which the body tends to move, opposite to which the body moves, not tends to move in this case, rather moves. Okay, and the ratio of F by R is equal to constant, that is given by in this case as mu kinetic. Okay, the dynamic or the kinetic friction in one and the same thing, because I have already told you the laws of dynamic friction or the laws of kinetic friction. Okay, but one important relation is mu s is greater than mu k, that is the coefficient of friction in the case of static friction is greater than the coefficient of friction in the case of kinetic friction. Okay, so there is not much to discuss in this class. I am just giving you a brief overview about the friction. Okay, now we will see the equilibrium of a body, equilibrium of a body on a rough horizontal plane. Okay, though I will be taking two numericals in this class to make you understand how to take the forces and all in case of a friction. Okay, so first of all, take a very basic question. See, if there is a mass m, body of mass m resting on this floor, between which they have the coefficient of friction as mu, and if this body is acted upon by a force F. Okay, so what all the forces will act on the body? Just draw FBD, that is the free body diagram. The weight of the body will act downward, that is equal to m into g. This is the applied load. Okay, these are the two forces that are visible. Now you can see, as I have already told you, since the body is in equilibrium, that means there must be some reaction in the upward direction that is counterbalancing this one. So that will be equal to the reaction force. Okay, and since this is a rough horizontal plane, that means there is a coefficient of friction, there is a friction between the body and the surface. So that will cause the friction force at this place. And according to the laws of friction, the friction force always acts in a direction which is opposite to the in which the body tends to move. Since the applied force is in this direction, so the body will tend to move in this direction. So the friction force will act in the opposite direction, that is F. Okay. So summation of forces in the vertical direction is equal to 0. That means R minus W is equal to 0, or R is equal to W. That is the normal reaction is equal to the weight of the body. Okay. Then in the vertical direction, if we find out the forces, see, in the vertical direction we find out the forces F minus FF. This FF will be equal to mu into the normal reaction R. Okay. So F minus FF or F minus mu R. Okay, this will be the force. But will there be a motion? What this will be equal to? Either this will be equal to m into a, or this will be equal to 0, or what? That depends upon one thing, the value of this applied load. As I have already told you that if this applied load, because this is the friction force, it has got its limiting value, the limiting friction. This friction force will not increase beyond that limiting friction. Okay, because this mu is a constant, this r that is equal to the weight that is equal to also constant. So this mu r is a constant value. If this F, the applied load, is less than mu r, then this body will be at rest. Okay, if this F is less than, because the friction force, as I have told you, made you understand in that example when there was a box kept and we were pushing it with the force of 10 kilonewton, 15 kilonewton and so on. So that time I told you that if the force, applied force, is less than the limiting value, then the friction force adjusts itself in such a way that there is no motion between the bodies. Okay. But if this friction force is greater than the limiting friction, then the body will move. Okay, so I will write these 2 points here. The first point says if F, that is this applied load, is less than the limiting friction, then body will be at rest. Okay, and if F is greater than, or you can say equal to as well, in the equal to case, though the body will tend to move, okay, it won't move but it will tend to move. So in this case, then body is in motion. Okay, understood this? Very easy to understand by that example which I already gave you. Okay, if F is less than the limiting friction, the applied force, then the body is at rest, or if it is more than the limiting friction, then the body will be in motion. Okay, so if this is more, then F minus mu r will be equal to ma. Okay, where a is the acceleration of the body. It depends upon this, will give you the direction of the body. This will be greater. Why? Mu r. Because if this friction force is less than mu r, then this body cannot move. This I have already given you. Because this mu r is the value of the limiting friction. If this limiting friction becomes, if this applied force is less than limiting friction, then this body will not move. Okay, so you cannot say that either the body will go in left direction, in this direction, or this direction. No, this is wrong. Why? Because the body cannot go in this direction, because the friction force, if the friction force is greater than Ff, this applied force, then it will be equal to it. It can't be greater than that. Okay, this is the special property of a friction force, that the friction force cannot get any motion. The friction force cannot bring any kind of a motion to itself, by itself. Okay, the friction force at max can be equal to the applied load, because it's a self-adjusting force. It cannot cause a motion by itself. It cannot happen that this mu r becomes greater than F and the body starts moving in this direction. No, this cannot happen, because this mu r is always this mu r will be equal to F till this F is less than the limiting friction. If this F becomes more than the limiting friction, then there will be a resultant force in this direction and the body will move in this direction only. Okay. Now we see a one simple case. If we have a surface, on that if we have a kind of a roller, okay, this is the center, this roller is rotating in this direction and it is moving, the body is moving in the forward direction. So this at point of contact, where will the force of friction act? Or basically we can say that which force causes this wheel or this roller to move in the forward direction, from where that force comes, because this is only rotating about its own axis. If you lift it up, just if you lift it up from the surface, the roller will still roll, or the wheel or the tire will still roll, but it will, the vehicle on which is mounted over this wheel or this tire, this won't be able to move in a forward direction. That means this surface or this point of contact has some role to play in the forward motion of this vehicle or this wheel. Okay, so that is the friction force. We say generally that the friction, that the body is moving in the forward direction. Okay, in the case of a box, we were saying that if the body is moving in this direction, the friction force is in this direction. Okay, we were saying this way. But here in the case of a roller or a rolling body, this concept changes. See, at this point of contact, this is moving in the backward direction. If you talk about, this is moving in the backward direction at this point of time. So the friction force will act in this direction. This is only the important concept that you must know. Okay, so this friction force is, this is that force, the friction force only, which is responsible for the forward movement of this vehicle or this wheel or this tire. Okay, so if a question, this kind of question has been previously asked in the examination, that which force causes the horse cart to move in the forward direction? Which force? It is the force of friction which causes the horse cart to move in a forward direction. Otherwise, you might also see one case if the vehicle gets sometime struck in a muddy water. Suppose this is the wheel and it gets struck into this muddy water, okay, or the dry sand, which does not offer any kind of friction to it. So the wheel will rotate. The wheel will rotate, but it will just splash out the muddy water or the dry sand from here. But this won't move forward. The forward motion is not there. Why? Because still the engine is running. If you say that the motion which causes the vehicle to move in a forward direction is the force that is produced by the engine, or that is the work that is done by the engine, no, that is wrong. The engine does the work to produce this rotating motion of this wheel. Okay, because if it would have been the engine force or the work that is done by the engine or the power that is developed by the engine, then in this case also the vehicle should have moved forward. Because in this case also the engine is rotating, the engine is running, this wheel is rotating, but why it is not able to move in the forward direction? Because it is not getting any kind of frictional force, the help of frictional force from this surface. Okay, this can be a muddy water or a dry sand. Okay, this is a very common example that you might have experienced also. Okay, if sometimes your vehicle, a four-wheeler or a two-wheeler, gets struck into a muddy water or the dry sand, it is not able to move in the forward direction, though the engine is running, though you are giving the full accelerator, the full throttle you are giving, but this is not moving in the forward direction, though it is rotating only. Okay, so that is the absence of friction in this case, which does not allow the body to move, or the rotating wheel or the tire to move in the forward direction. So the force which causes any vehicle or any rotating device or a roller or a tire or a wheel to move in the forward direction or the backward direction is the force of friction. Don't forget that. Okay, see. So now I have two questions for you. Okay, though they will be a bit of a lengthy questions as if we talk about the level of the JE exams, but I found them useful because in that you will understand the resolution of forces and all. Okay, so let us start those questions. The questions are like this. See, the first question is, this is a block. Okay, this is a block of weight W. In one case, it is pulled by a force of 180 Newton applied at an angle of 30 degree, and it just starts to move. Okay, when applied by a force of 180 Newton. The same block resting on the same surface tends to move when it is pushed by a force of 220 Newton applied at the same angle of 30 degree. Okay, in both the cases the block just tends to move. So you have to find out two things, that is, one is the weight and other one is the coefficient of friction. These two are to be found out. Okay, so just only from this question you can learn from very important concept, that if the force is applied at an angle to the body, this is the force that is applied at an angle, this is the pulling force, this is the pushing force, both are applied at an angle. So if the force is applied at an angle, then it is easier to pull the body than to push it. Okay, because for pulling you just require a force of 180 Newton, and for pushing, in the case of push, you require a force as high as 220 Newton. Okay, so sometimes there are some informations or some knowledge that can be learned from the questions itself. This is one kind of a question that is. Okay, so it's a very simple problem. I will just take one by one both the cases and try to solve it. See, case 1 I take of a pull. Just drawing the FBDs, nothing more to do in this. This is the center of gravity, weight is acting downwards. This is the force of 180 acting at an angle of 30 degree. Okay, there is an reaction, suppose R1. Okay, and if the force is moving in this direction, is applied in this direction, that means the body will move in this direction only, tend to move. So the frictional force will act in this direction. Okay, simple, FF1, or we can, okay, FF1, simple. Now resolving the forces in the vertical and the horizontal direction, since the body tends to move, we can just say that the motion has just started. So both the forces, that is horizontal equal to 0, vertical equal to 0. Okay, just write the equations. In the horizontal, if we write, we get the equation as 180 cos 30 degree, 180 cos 30 degree minus this friction force is equal to 0. Okay, 180 cos 30 minus FF1 is equal to 0. Got it? And in the vertical direction, if we write, we get the equation as R1 plus, and this FF1 will be equal to what? This will be equal to mu R1. But from where this R1 value will come? This R1 value will come from here. See, R1 minus R1 plus, first of all it will be plus 180 sin 30 minus W is equal to 0. Okay. So from here you can get the value of R1 as W minus 180 sin 30 degree. Okay, just substitute this value here. You will get this as 180 cos 30 degree minus mu. R1 value is this, that is W minus 180 sin 30 degree equal to 0. Okay, so 180 cos 30 minus mu times of R1. R1 is this, that is W minus 180 sin 30 degree equal to 0. This you get as equation number 1. Okay. Now, taking the second case, just I will not be rubbing this equation because that is what we require. Now taking the second case, taking the case 2 of push. Okay, so if this is the body, the push is there of 220 Newton applied at an angle of 30 degree. This is weight W, this is normal reaction R, and if it is being pushed, so the force of friction will act in this direction now. Why? Because the body will tend to move in this direction. Okay, so again the summation of forces in horizontal equal to 0, summation of forces in vertical equal to 0. So in horizontal, if we write it as 0, so this will be 220 cos 30 degree, that will act in this direction, this one, minus FF or minus simply mu R2 is equal to 0. Okay, and in the vertical direction we can write that R is R2, we can write it as R2 acting in the upward direction minus this will be acting in the downward direction, that is minus 220 sine 30 degree, 220 sine 30 degree plus W is equal to 0. Okay, so from here we can find out the value of R2 as R2 equal to 220 sine 30 minus W. Just substitute it here. You will get 220 cos 30 degree minus mu times of 220 sine 30 minus W. Okay, so this is equation number 2. This equation also has mu W, this also equation has mu W. Okay, just solve these two equations, two unknown, and you should get the value of mu as 0.173 and the value of W as 991 Newton. Okay, these are the two values that you must get. This question was basically, first concept was this, that the pull is easier than pull, first concept. Second is just to make you understand how to resolve the forces. Though this kind of question will not come, that I also know, but this was just an important question to make you understand how to have the understanding of the resolution of the forces. Okay, now I will just be taking one more question that will make the things more clear to you. Okay, see. See this case. Now there are two blocks. Okay, there are two blocks resting one over the other. This is block A, this is block B. They are resting over one another. Okay, and this block is tied to some string. This block is tied with an string at an angle of 30 degree. Okay, the weight of block A is suppose 1 kilonewton and the weight of block B is equal to 2 kilonewton. And between this block, friction force is the coefficient of friction is 0.3 and this is resting on a surface where also the coefficient of friction is 0.3. Okay, so now you have to find out and there is a force that is applied. So you have to find out the value of P for which the bodies will start to, this body B will start to move. Okay, how to find it? It's very easy, nothing much to be done in this. See, we will take both the bodies one by one, make the equilibrium equations for them and find out the value of P. See how. Let me write these values here. Weight of A equal to 1 kilonewton and weight of B equal to 2 kilonewton. Okay, so for the block A, there will be a weight that will be acting downwards, that is weight of A. Upward there will be a normal reaction, suppose RA. Okay, from here in this string there will be a tension T that is acting at an angle of 30 degree. Okay, and if there is a tension T, that means the body will tend to move in that direction. So in this direction there will be a friction force FF of A you can write. Okay, so these are the forces that will be acting on the body A. So for that, if you want to write the equilibrium equations, summation of forces in the vertical direction equal to 0, that means RA is equal to WA. No, right. Why? Because this force is also there. So RA plus T sine 30 is equal to WA. Now this is right. RA plus T sine 30 is equal to WA. First equation. Summation of forces in the vertical direction made equal to 0. Why? Because it is given that the system or the bodies are in equilibrium. That's why the forces of the summation of forces in the vertical direction is equal to 0. Similarly, the summation of forces in the horizontal direction equal to 0. That means T cos 30 degree minus mu RA, because FFA is nothing but mu RA, is equal to 0. Okay, got it? So from here you can write, from first equation you can write T sin 30 is equal to weight of A, that is 1. So 1 minus RA, and T cos 30 is equal to mu RA. The value of mu is 0.3, so 0.3 RA. Okay, now there are two equations and two unknowns. Either you can find out both of them, but the tension is not required because we are required to find out the force P. So no need to find out the tension here, just divide this equation this way. You will get the value of sin 30 by cos 30, you will get the value as tan 30. Tan 30 value is 1 by root 3, so that will be 0.577 equal to 1 minus RA over 0.3 RA. So from here you will get the value of RA as 0.85 kilonewton. Okay, but this RA is not required. We are required with this force P. This we got. Okay, so now writing this value here, okay, RA equal to 0.85 kilonewton. Now, drawing the FBD of the body B, the weight will act in the downward direction. The reaction from this surface, the bottom surface will be there, that is RB, and the weight will also act of this body on this. Okay, so there will be weight of B plus weight of A. Okay, on this upper body the force of friction was in this direction. So in this, on the top surface, the force of friction will be in this direction, that is FF of A. Okay, and in this surface, if there is a force P that is applied in this direction, so the force of friction due to this will be in the backward direction. So this is the free body diagram of the body B. Okay, now again writing the equilibrium equation, summation of forces in the vertical direction equal to 0, that is RB is equal to WB plus WA. RB is equal to WB plus WA. Is it right? Yes? This will not be WA. Why? Because there will be the effect of this one as well, the tension. So there will be the reaction that will be acting here, that is RA, not WA. Why? Because if it consider only WA, then the effect of this goes out. Okay, so just keep in mind it will be WB plus RA. Okay, so WB plus RA, RA value we found out as 0.85, WB is 2. So this RB will come out to be equal to 2.85 kilonewton. Okay, now FF of A will be equal to mu into RA. Mu is 0.3, RA is 0.85, RA is 0.85. So this will be equal to 0.255 kilonewton. This is F, friction force due to A, that is on the body A, and FF of B will be equal to mu into RB. Mu is again 0.3, RB is 2.85, so this value will be 0.855. Okay, and writing the equilibrium equations in the horizontal direction, that is the summation of forces in the horizontal direction equal to 0. That means P this one, P minus FF of A minus FF of B is equal to 0. Okay, or P equal to FF of A plus FF of B. FF of A, the friction force due to A on the surface A is equal to 255 plus this one is 0.855. You will get this value on addition as 1.11 kilonewton. So 1.11 kilonewton of force is required to just move this body in this case. Okay. So this is not that much difficult problem, though it is not expected at the JE level examinations. Okay. But you must know how to resolve the forces. That is what the motive behind making you solve this kind of problems. Okay. The motive behind solving this kind of problem was to just make you understand that how you should resolve the kind of forces. Okay. Though I am saying that though the numerical chances of this much level is not expected in the JE examinations, but this kind of equations can be asked, that what are the equilibrium equations in the horizontal direction for the body, or the equilibrium equations in the vertical directions for the system of bodies that are given here, or this force, this system of forces. Okay, so that you must know. So that is why this is the motive behind making you solve or making you understand these kind of problems. Though don't worry, these kind of problems are not going to, you will not see these kind of questions in the examination. Okay, so just to make you aware of the resolution of the forces and all. Okay, so thank you.